right, the r squared equals 0.75. They want us to interpret it. What that means is that 75% of the total variation, so you'd say 75% of total variation can be explained, is explained by the regression line. Is explained by the regression line. And you need to know that because there's going to be times when they ask you that on the exam. So number 2 says, explain what is meant by total deviation, explained deviation, and unexplained deviation. All right, the total deviation of a data point is the difference between the observed value, y, and the mean y hat. The explained deviation is the difference between the predicted y hat and the mean. The unexplained is the difference between the observed and the predicted. So let's write that down. Okay, the total deviation will be whatever the observed is minus the mean. That is the total deviation. The explained deviation is the predicted y hat minus the mean. And then the unexplained is going to be the observed minus the y hat. And if you had a graph, it would basically look like this. This is my y bar. This is my x bar. And let's put the line kind of like this. And what we have here is our observed, so that's my y. This is my y hat. And so here is your total from the y to the y bar. There is your total. From the y hat to the mean is your explained. And then here to the y hat is your unexplained. Now let's see what number 3 says. Okay, in number 3 we want to know what does it mean if our residual plots has a pattern. What it means, if I have a pattern, it may mean that the response variable and the explanatory variable may not be linearly related. All right, in number 4, they asked what is a constant error variance and why is it important? Constant error variance says that the error of the prediction, which is your y values, does not depend on the explanatory, which is the x values, and it's constant for all your values of x. And that means why it's important is that you can actually, the reliability of predictions is the same no matter what your x variable is. All right, the next question is what is an influential observation? An influential observation is one that significantly affects the correlation coefficient, the slope, or the y-intercept. So if it affects the r and it affects the b1 or it affects the bo, then it is an influential observation. If an influential observation is observed, it should be removed only if it can be justified. If the observation cannot be removed, then you either need to collect more data so that collect more data near where the influential observation is, or apply other techniques that reduce that, and those techniques aren't going to be discussed in this class. Number 6 says explain the difference between an outlier and an influential observation. An outlier is a point that does not fit the overall pattern of the data. An outlier may or may not be influential. A point that is not an outlier may be influential if its x and y values are far from the rest of the data. Number 7, we are asked to explain how an influential observation affects the least squares regression line. Well, an influential observation can change it'll either change the slope or it'll change the y-intercept or both. That's how it affects the line. Number 8 says explain how a violation of the constant error variance assumption might affect the confidence placed on a predicted value. If the constant error variance assumption is violated, then the error of prediction is going to vary with the value of the explanatory variable, which means it's going to be less reliable. So in other words, if if the constant error variance is not constant amongst the x values, it's going to be very hard to predict what your y values are going to be because it's not as reliable. All right, number 9 says if r squared is 0.81, can you determine the value of r? In other words, can you find r? And if so, what is its value? And if not, what else do you need to know? Okay, the residual analysis, the least squares line. Notice we got to get used to seeing it this way. Yes, we've always written in algebra as y equals mx plus b, but this is how they write it in the stats land. So we want to explain why it's important to do a residual analysis. And the reason it's important to do a residual analysis is we have to know if it's appropriate to have a linear model. So we want to know if there's a constant error variance. We want to know if there's a pattern between the x and y variables. And if there is not a pattern, then we can look at the least squares line. And if that's not the case, then we want to look at any outliers and see what's going to be affecting the linear regression line. All right, when we look at number 15, we need to match the r squares. Now, keep in mind it's squared, so there won't be any negatives, to the graph. This is a almost perfect fit, so right away, this one's going to be r squared equals 1. The one that has the least amount of pattern or looking like any kind of line should be the one with the lowest r squared. Now I have to look at these. This looks like it's more of a pattern, so it should have the higher r squared, and this one should have the middle of the road one. All right, so here is the data. And we stick it into the calculator, and here is the scatter plot. It looks like it could be linear, so I would say that it's a positive linear association, but I need to verify. So now what we're going to do is we're going to look at the residual plot. So here is the residual plot versus the time. Now if you think about it, it looks like that we have, it could be constant. It could be that it looks like it's a pattern, or it could look like it's spreading. But I don't think so. I think that there is an actual constant here. It's varied, so that the linear regression would be an appropriate model to use. Okay? Now, it says the coefficient of determination is 83%. What that means is that 83% of the variation in the length of the eruptions, in other words, most of the variation in how long that Old Faithful geyser erupts can be explained by the least regression line.